Let's look at part C. Ultimately, at the root of this thing, right, is that the efficiency is going to be output over input, right? So 23% means that 0.23 is equal to the output over the input. Now, the input is what we're trying to find, right? That's the question, right? The output we have to calculate first, okay? So maybe my first step is to figure out the power output, right? Okay, so power is work divided by time, right? Or energy divided by time. The work could be the force that you calculated, and you calculated this in part B, right? Times the distance you calculated in part A divided by the time that they give you. That's one way to do it. Another way to do it, to find, then this is the power output, right? Okay, another way to find the power output is to use force times velocity, right? Use the force you got from part B, right? And use the average velocity, right? And the average of 27 and 0 is 13.5, right? Okay, so the average power, right? Because they're talking about the average power, right? Another way to do it is to, and these all should be about the same, is to say it's the energy over time, and the energy is the kinetic energy, right? So 1/2 mv squared divided by the time, right? And I will leave that entirely up to you how you do that. You could do it all three ways. I'll just pick one, okay? So that, whatever you figure out for this is going to go into the power output, right? Okay, and then ultimately I think what you end up dividing by 0.23, because if it's only 23% efficient, much more power has to go in, right? All right, happy hunting.